So this is question 9 of Mock A, and it starts off as a difference equations question, so probability, and then goes into second order difference equations. So in the word game Scrabble, a player scores a bingo when they use all 7 tiles in the rack, and we have a professional player. This one's going to be weird. And she wants to sort of calculate the probability for getting a bingo. So the first question, actually, we're told statistics first, is that she gets a bingo about 15% of the time. So I'm just going to write that as 0.15. And if she gets a bingo, she gets another bingo in the consecutive turns 62% of time, 62% of the time if there are sufficient tiles left. So that's 0.62. So find out probability that Cheryl does not have a bingo on her first 4 racks. Well, not having something is 1 minus the probability of 4 bingos in a row. So that is 1 minus. The first time she gets a bingo is 0.15, and then it's 0.62 cubed. Now, if we work this out, 1 minus 0.15 times 0.62 cubed is. Now, we're going to take this to 4 decimal places as probability does 0.9643. Find the probability that Cheryl encounters her 4th bingo on her 9th rack. Now, this question is actually slightly more difficult than I originally intended it to be. But how this works is it's not a binomial because the probability changes. So we're actually going to have to think of these situations separately. So either she gets 3 bingos in a row, she gets 2 and then 1, 1 and then 2, and then 0 and then 3. Now, what we can actually do is that because 0 and 3, so 3 bingos in a row is the same as this, what we can actually do is calculate these probabilities and then times them by 2. So hang on, let me rejig this. So either she gets 3 bingos in a row and then nothing. So 3 in a row, either 2 in a row, then 1, 1 and then 2 in a row. And that's really all, because then 0 and 3 in a row is the same. So what this will be is the 3 in a row at any point is 0.15 times 0.62 squared, and then a bingo. 2 in a row and then 1. Well, she gets 2 in a row, that's 0.15 times 0.62, then another, and then 1, so 0.15 times 0.15 times 0.62, and then times 0.15. And then we just have to add all these probabilities up. So this is going to take a while. Plus 5 times 0.15, and then plus the third instance. And we get a probability of 0.0128. So write down a difference equation which represents the probability of Cheryl playing a bingo on her nth turn after playing a bingo. Use Pn to represent this probability. Okay, so either two things can happen. Either it's the probability of getting a bingo and then getting bingo again, or the probability of missing and then getting a bingo on the next turn. So after a certain amount of bingos, she'll have Pn as that probability times by getting a bingo again. So the probability of getting a bingo again for her after getting one already is 0.62 times 0.62. Now the probability of missing is 1 minus the probability of getting it times getting a bingo again 0.15. So either of these can happen, so we add them together. So we get 0.62 Pn plus 0.15 minus 0.15 pn. Now these are going to cancel each other, right? 62 minus 15 is 47. So the actual probability is going to be 0.15 plus 0.47 pn. And we can actually write p as the probability of getting a bingo on our next rack. Now, this is a difference equation, however, we have to solve it. Now, I did do one method for the rhinoceros. It doesn't matter. So now I'm going to do the separate method. So the first part of the solution says that the probability is equal to the growth rate, which is 0.47. So a constant C1 times the growth rate divided n. The second solution says we have a second constant is 0.15 plus 0.47 times that same constant. Now that'll be 0.53 C2 is 0.15. So that'll just be 15 over 53. So that's that second constant. Then we put 1 and 2 together. So that leaves that the probability is C1 times 0.47 to the n plus 15 over 53. Then we can put in the original probability, which is 0.15. So that'll be 0.15. That disappears. That just becomes, if that's 0, it becomes just C1 plus 15 over 53. So C1 is 0.15 minus 15 over 53, which we get as a bit of a mad number, minus 141 over 1060. So the actual probability is C1, so minus 141 over 1060 times 0.47 to the n plus 15 over 53. Now that doesn't look right. Although 1060 is a multiple of 53. So use the answer from part 1 to show the difference equation is valid. Now, if this is incorrect, I'm very sorry. I'll probably re-record this at some point because I'm doing them all in one take, but I'm uploading them in 5 video chunks. So I'm very tired. So let's just see how this works. So from part 4, we just sub in 0.47 to the power of 4 plus 15 over 53. And then we 1 minus that. We get 72. So that's nowhere near. So either one of these is probably incorrect. So I'm very sorry. I will probably just re-record this at some point. As I'm trying to do them all in one take, as I said, uploading them in 5 video chunks. Uh, if anyone wants to do this question, have hopefully an answer that can be proven with part 4, do let me know. Anyway, second order difference equations now. We're told iron weeds are a common weed, blah, 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 blah. Random stuff. Number of weeds in tens, found in a region of Texas. After n years is Wn is 2 Wn minus 1 plus 3 Wn minus 2, where Wn is the number of weeds. The nth year after January 2010. So solve the difference equation. So we're going to start with characteristic. So we move everything to one side. I'll write as Wn minus 2Wn minus 1 minus 3Wn minus 2. So the characteristic is m squared minus 3m, or minus 2m minus 3 rather. So that should be a 2 minus 3 equals 0. We can factor this as m minus 3, m minus 1, m plus 1. And so we get that m is 3 or m is negative 1. So the solution, therefore, is Wn is C1 times 3 to the n plus C2 times negative 1 to the n. Now we're going to put in our values. So W0 is 100 So 100 is, both of them are going to be 0, so it's going to be C1 plus C2. W1 is 200. So 200 is 3C1 minus C2. And that actually works very nicely because we can put the 100 in here as C1 plus C2. That's from just equation 1. These are going to cancel. We get 300 is 4C1, so C1 is 75. C2 will have to be 25. It'll be 300. 3C1 is T25 minus that's 200, 75. Yeah, no, that works. So we can write that Wn is C1, so 75 times 3 to the n plus 25 times negative 1 to the n. And that is our solved difference equation. Put a nicer box around it. There we go. Estimate the number of ironweeds in June 2015. Now, there are two problems with this. It says number, and it's June, but we're measuring in January. So the way to do this is to find the ones in January 2015 and January 2016, and then take x bar. So we're just taking the arithmetic mean of them. So firstly, 75 times 3 to the 5 plus 25 times negative 1 to the 5 is 18,200, but remember that's in tens, so it's actually 182,000. Then we do the same thing, except we put a 6 in there for 2016. You get 54,700 minus 547,000, and so x bar is 182,000 plus 547,000 over 2. And we get the average is 364,500. Now, the reason we're doing this is because if you actually type minus 1 to the power of 5.5, it'll give you a math error because negative 1 to the power of n is actually only defined for positives. Let me just double check that. Minus 1 to the minus 2. Yeah, so for only integer values that are not 1. So that's why we're going to do that. Find the rate of change between 2022 and 2023. So in 2022, that's 12 years after, so it's just more calculation. So 75 times 3 to the 12 plus 25 times negative 1 to the 12. Right, so we've massive numbers here. 39858,100, and then we add an extra 0. And then we just add a 13 instead. So in 2023, 119574200 minus 398581000, and the change in weeds is 797161000. So 797,161,000 ironweeds. A supernatural being encounters this region of ironweeds millions of years in the future. Describe the number of ironweeds the beings might see. Neglect the fact that the Earth might be swallowed by the sun in this time. Well, we can see that the 3 to the n will definitely outpace the negative 1 to the n because it will only tick down by 25 every odd year. So what we can say is that the ironweeds tend towards infinity. So just trying to be quirky with this, the Earth might be infested with ironweeds. And that is hopefully a good enough answer for Mock A question 9.